So can you hear me? Yes? Okay. So thank you everyone. So I will start fast because I have a lot of things to say. So my presentation will be mostly about machine translation, finding an equivalent for a sentence or a text in one language, finding an equivalent into another language, right? And I will present how recent advancements in LLMs, large language models, and so on could allow a number of languages that for now do not have access to this kind of technologies to have machine translation models and things like that. So machine translation is a very old technology. Actually, it's more or less linked to the first developments in artificial intelligence. The first machine translation system translating from Russian into English was released almost 75 years ago, right? So this is the newspaper. And the first paper that applied the encoder-decoder architecture that now is used in basically every AI model, neural network model, or most of them, the encoder-decoder architecture was introduced in this paper, and actually the experiments were dealing with machine translation. A couple of years later, the first paper introducing the idea of attention in natural language processing, guess what? The experiments were about machine translation. And finally, the architecture that 99% of the models is using, the transformer, was published a few years ago, and it contained experiments only for machine translation. So machine translation is behind most of the advancements in natural language processing, especially because it implies two things that are very relevant for any other task, which is you need to understand natural language understanding the input text, and then you need to be able to generate the text in the target language. So a few months after the publication of the release of the transformer, there was some papers, for example, this one by Microsoft, stating that they had achieved human parity in their machine translation models, meaning that the performance of the machine translation was equivalent to that of a human. There were a lot of criticisms to this paper, and actually probably it wasn't completely like that. But a few years later, this is the WMT, which is the most important conference in machine translation, the workshop in machine translation. It has a number of competitions where different teams send their machine translation models. And for the first time, and this is an independent evaluation, for the first time, they found that in the case, at least, of English into Spanish, the system made virtually no mistake in thousands of languages when translating. So it could seem that machine translation is a problem solved. So I finished my talk because there is nothing to do. Thank you. Okay, no. So what is happening here is that there are thousands of languages in the world. Machine translation is not a problem solved because you have literary translation and some other stuff and cultural stuff and things that are not fully attained by the systems, but machine translation works very well for a few selected languages, dozens or a few hundreds of languages, let's say, but there are around 7,000 languages in the world, right? And so here you have some of these privileged languages in the sense that they have enough resources or somehow some resources that allow them to be used in AI models. So this is the list of languages in Flores 200, which is a data set used for machine translation evaluation. And these are the languages included in the Small and Gatitos data set by Google, which is also something similar. So these languages are privileged, not obviously in different levels, because you may find some resources for them. But remember that there are thousands of languages which are not so privileged. And the idea is that we call them low resource or even extremely low resource languages, and they represent more than 95% of the languages of the world. And the truth is that current machine translation models perform very bad with all these languages. So how difficult is for example, an LLM, a large language model, to deal with these languages which the model has never seen before. So in order to give you some idea about that, I will compare the processing of these languages with some other problems. For example, this is the ARC dataset, which contains a number of problems that are supposed to be really difficult for current models. And the idea is that you have some input and some output. You have a few examples, two in this case, and then you provide the model with a new input, and the model has to determine which is the output. This implies usually some reasoning, some logic deduction, and things like that. And the current models perform around 10 or 20%, right? So the score, the performance is really poor until now. And this is a data set which is called Linguini that contains problems dealing with linguistics. So they come from the International Linguistic Olympiads, right? So the idea is that humans get these problems in which they are posed with questions related to languages they have never seen. But, humans with some background in linguistics, the idea is that the general knowledge about linguistics that they have allow them to answer many questions and to translate, for example, into these languages which are unknown for them, or find equivalents or generate text in those languages. So Linguini is a data set that is included in the Big Bench Extra Hard, which is a data set of problems that turn out to be really, really hard for machines, at least as of today. And Linguini actually is one of the data sets included in this data set that is harder for computers or for AI models. Actually, the performance is around, more or less similar to ARC, to the other data set, is around 10 to 20%. So that means that there is a lot of things to do in order to make these large language models be able to deal with thousands of languages in the world, right? And this is a relevant paper published like 1 year ago or less. They showed that, okay, what if we give a grammar book about a language that the LLM, the large language model, has never seen? So these models that are supposed to get so good results in maths and physics, they say that an LLM will get the Nobel Prize for chemistry or physics in the coming years. So couldn't they read a grammar book and then get the understanding of how that language works and use that in order, for example, to translate or to generate text into those languages? So this paper worked with Kalaman, which is a language spoken in Papua New Guinea, in Indonesia, and they proved that the grammar was useful and that by adding that to the prompt of the model, the quality, the performance of the model in machine translation improved a lot. So here you have like an example of the grammar. Usually the grammar is written in a dominant language, for example, English or Spanish or something like that, and describes, the grammar book describes the language itself. So from that moment, a number of papers appeared that try to do the same with more languages, right? And I want to show you this graph here. It shows that among all the languages in the world, around 60%, this is quite optimistic probably, but let's say that between 2,000 and 3,000 of languages in the world have something like a grammar book. And actually more of them have some kind of dictionary. So the idea is, could we use these resources in order to teach all these low resource languages to LLMs, for example? Which resources? Okay, again, grammars, for example. These are of a project we are currently working. So this is an example of a grammar in Canjobal and Cachiquel. They are Mayan languages spoken in Guatemala. We also have some resources that are very valuable. For example, the Little Prince book is the non-religious text which is in more languages in the world. So there are more than 600 languages that have the Little Prince, right? And we are also working in using this small text, which is multilingual, in order to get knowledge about some languages. We also have glosses, which is you have a sentence in the language, and then you have some annotations of the equivalent words or morphemes in English, and some morphological description of each of them. And some data sets like this, they contain glosses for nearly 2,000 languages of the world. So this is a really, really interesting resource. We have dictionaries. This is a dictionary for Canjobal, the Mayan language I told you before. And we have things like GramBank, which is really interesting. GramBank is a collection of hundreds of different features that languages may have or may not, or may have in different levels. For example, do they have definite articles? So you have a description of the feature, and then you have a very long table with thousands or hundreds or thousands of languages describing whether they have this feature or not. Right? So all this information could prove very useful, and the idea is, you know now what we can do. We prompt the model, and we give all the information about the language in order to translate. So we start by saying, you are a translator, you are very good, blah, 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 blah. This is an example for one of the languages we are working, which is Bribri, spoken in Costa Rica. And so we ask the model to translate this sentence. And the idea is that we then provide a lot of information, morphological information, if we have it, about the sentence, similar or exact or the same words if we find them in the dictionary, the definitions or the equivalent in the other language, some relevant translations of similar sentences, and some paragraphs coming from grammar books. And then we ask the model, now proceed with the translation. So one of the projects that we are working related to this idea was awarded with a Google award a few months ago, and we are digitalizing a number of resources in different Mayan languages, spoken mainly in Guatemala and Mexico, and we are developing also data sets and machine translation technologies for these languages. So this seems, again, very promising. So, okay, we give all the information that we may find about that language, and the LLM will do the rest. Okay. Some paper published like a few months ago, this is version 2, but it's 3 or 4 months old, showed that everything is not so shiny, right? They analyzed those papers using the grammar books in order to teach the LLM a new language, and they showed that basically the LLM was ignoring all the grammar or the grammatical information here. The LLM was focusing on the examples in the source and target language here, and actually if you remove all the grammatical blah, blah, blah stuff here, the model performs better. So that means, again, that we have still a lot of things to do, because we may consider that these LLMs that are so brilliant in maths and physics and so on should be able to understand what is being said here and apply it consequently. So there are a number of different things that LLMs are including these days, and that could prove really, really useful here. One of the things is reasoning models. Everyone is using reasoning models. There are different ways in which you can teach a model to reason. I will mainly focus on the fourth one, which is reinforcement learning with verifiable rewards. This was one of the first papers, was the DeepSeek paper last January or so. So the idea is that you ask the LLM to solve a problem, but you ask it to think before giving the answer. So the idea is you please think a lot about that and then provide an answer. But you do not compare the reasoning with any ground truth. You just verify whether the answer is correct or not, or the degree in which it is correct. So the idea is that just by doing that, it can be shown that when training proceeds, the model, the length of the reasoning becomes longer and longer. And at the same time, the performance on some math and coding problems improves at the same time. So the idea is that the model is learning to reason by itself by using reinforcement learning. So how can we translate or move these ideas to the idea of machine translation? Well, we may train an LLM to think before providing the translation, and to think by using reinforcement learning with verifiable rewards. And then we check the answer, and we compare the answer with a correct translation, and we use that as the reward in order to make the model to think better about how to translate that. So the idea is that we still provide all the information, morphology, grammar books, and so on, but we let the model to think before translating. So I will skip this. And another topic is translation agents, which is the idea of having different LLMs with different specializations. For example, this is the virtual lab in which they perform some developments related to biomedicine. And the idea is that you have some LLM, which is the principal investigator of the team. You have a critic, you have an expert in machine learning, an immunologist, and so on. And they, by using natural language, they reason about the problem, they try to solve it, everyone according to their experience, to their backgrounds, and they have these team meetings in which they use natural language in order to have a conversation, in order to find to the correct answer at the end. So we can, again, we can transpose all these ideas again to the field of machine translation by having different roles, for example, a senior editor, a junior editor, a translation, a localization expert, a proofreader, and they cooperate by using natural language in order to perform the translation. And finally, agentic RAG. This means that until now, when you have the grammar book, this is usually very large, so the idea is to select the paragraphs which are better in order to perform a particular translation. In order to do that, there is this technique that probably most of you know, which is retrieval augmented generation. You perform some query, and then you compute the embeddings, and you do some similarity in order to find the relevant passages in the book. But we can use reasoning and agents in order to do this. This is called agentic retrieval augmented generation. That means that you have the model, well, okay, I have to translate this sentence, I have all this information, I read the grammar book, and then I decide for every paragraph there whether it is relevant or not in order to perform the translation. And once the model has reasoned about the best paragraphs to perform the translation, it copies those paragraphs into the prompt in order to perform the translation. So I have shown that new techniques for machine translation could be very useful in order to to understand and translate all these low resource and extremely low resource languages. I have described some of them here. And just to finish, what I have shown you here is just a midterm project. Our idea in the long term is to go beyond this and to have models or devices that learn new languages by interaction with their speakers. So the idea is that ChatGPT created this, the device is so beautiful, it looks like it has eyes. So we have a device and we give it to the people in speaking a particular language in the middle of the Amazon, for example, and then the model, by using things as curiosity-driven learning and things like that, it interacts with the speakers. Okay, why did you say that? Why when you are happy you say that, but when you are sad you do the opposite? Can you tell me, can you explain me what this word means, and so on? So the model is able to interact with the speakers to get knowledge and to improve by immersion the knowledge of the language. And then once the model has some skills in that language, it can act as a mediator, being a companion, going with the person to the city, to the metropolis, and helping them to have conversations with, in the bank, with the doctor, with the lawyer, and things like that. Right? So the idea is learning by interacting with the speakers, and finally becoming a mediator, helping those speakers to communicate and to develop in the city where there is probably some predominant languages, some predominant or dominant language which is not the language they speak. And that's it. Thank you.
Any question for?
Okay. Thank you for a very beautiful talk. I want to know, has that following problem that is closely related to what you said in the last slides, yeah, has that been studied? A minimum number of questions from which you can learn an entire language. If you ask these questions, get the result back, you can ask other questions and others, but you need a minimum number of starting questions.
Yeah.
You see? A minimum set of questions for any language without even languages with no writing, then you do the transliteration or you write it in some phonetic language, okay, and you do this with hundreds of people, of course, yeah, so that, and then has that been studied? Is there a catalog of a minimum number of questions such that from those questions you can learn the answers? The answer allows you to put another question, etc. You build a tree of questions basically from which you learn the entire language.
Yeah, I understand what you are saying. Actually, this is more or less related to active learning, which is how to make the questions about the minimum number of sentences that allow you to learn.
Yeah, but it's a little bit, linguistically, it's also semantic because you need to get into all domains from this and to explore everything.
I'm not aware of papers, I guess, because everything that, if I say, that's a great idea, let's try to do that, probably we will search, and there are like 10 papers last month published about that. I'm not aware of them, but that's a very interesting idea.
That could be the seed of such a system that you don't even need assistance because you just need these few questions, the first few answers, first questions.
But at the same time, for example, the device, it's better that you do not, people do not have to change their everyday lives. So I'm not completely sure whether.
No, that's clear. Yeah, but
Thank you, Juan Antonio. I read something about that, but I don't know how the things are now. So I am asking if you know it. What is the situation about languages that are only orally transmitted, where there's no written at all?
Yeah, there are many languages with an oral tradition and have no written form, right? And that's so interesting because there was an UNESCO conference about multilingualism a few months ago, and there was this indigenous woman from Canada, and she was saying that our language is oral, and we do not want it to be encoded in written form. But linguists came from the outside world, and they decided to have like a system for that. So there are many cultural and ethical things to be taken into account here. But the idea is that there are also advancements in doing unsupervised learning. So you are able to transcribe you have some audio, and you somehow determine the phonemes or phones or something like that. And then you have a small text, not necessarily correlated with the audio, and then you are, by using the frequency of different patterns, you are able somehow to transform that. So there are a lot of, let's say, improvements, because advancement seems to be over there now. There are a lot of improvements in supervised transcription of languages, which is also something really interesting.
So when you look at these unusual languages, or those that we don't know about, doesn't it ever happen that they have concepts, words for concepts that do not belong to other languages? So how do you do for translation?
Yeah. That's an issue with translation, and it's been studied by translators for years and years. And so that's the idea of also that translating is not only the words, it also has some cultural issues and things that have to be taken into account. But I guess that the models could somehow, the same as humans, end up finding some equivalent, right? So there is, for example, you know Tokipona. Tokipona is a language with only 100 words. It's very nice if you want to learn it. So instead of crying, you say I have water in my eyes and things like that. And Tokipona manages to represent a lot of things with only 100 words, so this is the opposite, but somehow I guess that the models should be able to deal with that. Yeah.
The last question.
I think there are two candidates, but you may ask me later if you want.
Thank you very much. My question is going to be not the minority languages, but the variations, for example, of a common language, for instance, English. And I mean phonetic variations and also lexical variations in terms of grammar. So can the model be adapted to this from the input, I mean?
Okay, so the answer is people are trying to do that, but I guess that, again, at the end of the day, we will find that models are able to automatically detect. So for example, you give the text in all the different variants, and then you say, I want you to generate a text following, and instead of giving names or labels to the variants, you just give an example of a few sentences. So the model is able to adapt. Actually, it's more or less what is happening right now with LLMs, because if you ask it in Valencian, they usually use Valencian forms for words instead of Catalan. So I guess that the idea of doing this again in an unsupervised way, without saying, I have 5 variants, so the model wouldn't mind whether they are 5 or 10, it will somehow manage to detect that there are some different patterns in different texts. And then if you give just one example, I want you to follow this particular variant, so the model will be able to adapt to it. Yeah, there are a lot of things that are being done about that.
Another question which is not directly related, but is it possible to learn a language by machine learning, basically neural network or whatever, such that you just listen at a conversation in this language, you don't interact, but from the conversation and statistics, you know, for instance, phone calls, you know a phone call will hello and the other one will say yes, and this guy is speaking, and then you know how often people usually say yes or no, then you learn what yes or no is, and etc. Are there such models that you just listen?
Yeah, but I guess that using
don't work.
Only monolingual data, I guess it would be, but we cannot say that something is impossible, because as we have seen for the last 5 years, everything that seemed to be impossible, but for a human also will be okay. It could be, but probably then you need multimodal models. Yeah. So you need vision, for example. Yeah. And so
okay, multimodal.
Yeah.
But the tone is also there. You know, the tone is also a modality. No.
Yeah. There are many things about that. Yeah.
But it's not yet. Not possible in this moment, probably, no? But that would be very interesting too.
I don't know, probably there were a couple of papers published yesterday about it. But yes.
Thank you.
Okay, so thank you for all the questions. Thank you very much.
Thank you.